Hey mathematicians, let's do our homework. Okay, so today's homework, we already did one problem. We did number 8 in class. And remember that it's all a review, so don't just be thinking percents. It could be about fractions, decimals, ratios, integers, ordering things. It could be about dividing. It could be about multiplying, adding, subtracting. All the things are possible. So keep your mind open. Let's try them one at a time. And number 1. Point A represents which of the following values? Oh boy, it's such a tiny graph. Zoom in, squint, figure out what it says. Here's point A. The first thing I notice is that it's between 0 and 1 whole. That means it's less than 1 whole. So these two options here, A and B, they're bigger than 1 whole. They would be between 1 and 2. That's not where point A is. So we're choosing between 1/2 and 3/5. I bet you can probably eyeball that and say A does not look like it's exactly in the middle. If I had to pick exactly in the middle, I think I'd pick it right there maybe. That does not look like it's exactly halfway between them. So final check. Between 0 and 1, I see 1, 2, 3, 4, 5. Ooh, that was 3 out of 5. It's D. Number 2. Daniel has 12 large brownies. Yum. If one serving is 1/8 of a brownie, how many servings does he have? So picture all these brownies, 1, 2, 3, by 1, 2, 3, 4. There's 12 brownies, and each of them, you don't even eat the whole brownie. This is just like a bite's worth. Each of these is cut into 8 small pieces, like that. And that's 1 serving. So we're trying to figure out how many servings are in the whole thing, the whole tray of these large brownies. Instead of cutting up this whole picture into 8s in each of those 12 bits, we're going to do a division problem, because when we think about, oh, I would have to cut it up, that is usually a division problem. We start with what we have. Daniel has 12 large brownies. And then the second number is the size of each of the pieces. Each piece is 1/8. Now, when we have a whole number and a fraction, we cannot divide them like that. They both need to be fractions. So 12 will become 12 over 1. When we have fraction division, now that they're both fractions, we can keep the first one, change the second thing, and flip the last one. So keep the 12 over 1, change my division to its inverse operation. I'm going to change it to multiplication. And then flip, the real word for that is find the reciprocal, which means that you had 1 and 8, and now it's in the opposite order. Now it's 8 and 1. Now we just multiply. 12 times 8, oh dear, is going to be our numerator. 1 times 1 is 1, that's our denominator. When we have a denominator of 1, that's really just saying we have a whole number. So whatever this number is, you can drop the over 1 part. That is your final answer for how many servings you'll have. Number 3, to which set or sets does the number -5 belong? Oh, this has been a very long time since we've done these. This was a Unit 1 question. So we remember that whole numbers are numbers you can count on your fingers. 0, 1, 2, 3, 4, 5, things like that. These are only positives, plus 0, which isn't technically positive or negative. And they're not fractions, they're not decimals, because I'm not counting like and 1/2 of a finger and 1/8 of a finger. We don't do that. So this is a 5 would fit here, but a -5 would not. So no to the whole numbers. And then I'm going to read through. Ooh, this one also says whole numbers, so we've already eliminated those 2 answers. Integers are whole numbers, 0, 1, 2, 3, 4, 5, and their opposites. The opposite of 0 is 0, but the opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3. The opposite of 5 is -5. -5 could fit here. What cannot fit here are decimals and fractions. Rational numbers are whole numbers, integers, and then the decimals, the fractions, the mixed numbers, the negative mixed numbers, everything we deal with in 6th grade. So yes, it could be a rational number, but it also needs to say integer. So rational numbers only is not going to work for us. C is our answer. Number 4, the table below shows the record low temperatures for 5 states. Which expression correctly compares 2 temperatures? So it's not necessarily saying like put them all in order. We're just looking for a true statement. Is negative 45 bigger than negative 23? No. I know that positive 45 is bigger than positive 23, but when we're dealing with negatives, the bigger it looks, the smaller it actually is because it's further to the left on the number line. So this one is not true. You're going to go through and just ask yourself, is this true? To each of these statements, only one of them is. On the back of your homework. This one we actually are putting in order from not least to greatest, from greatest to least. So make sure you read closely because sometimes it'll say least to greatest, sometimes it'll say greatest to least, and you don't want to just blindly be like, I think I know what they're going to ask me. You need to actually read it. And my best advice is change them all to the same form. So I see 2 decimals, 2 fractions. Life would be easier if they were all the same type of number. And I personally think life is easier when they're all decimals. This one is very easy to change to a decimal. It is 0.56. This one is harder. Sixths do not nicely scale up to 100. So we actually probably want to divide that one to get our decimal value there. And then you're going to go from greatest to least, which means that you are looking for the biggest number first. Just by comparing these 3, and maybe 5/6 is going to actually end up being the greatest, but just comparing these 3, I look at the 10th place, the 10th place, and the 10th place. Just between these 3 options, the Longhorns is the greatest, and the Vaqueros are the least. You need to actually figure out what this decimal is before you can really make your list because we're not sure what that number is yet. For number 6, a coordinate grid is shown below. What ordered pair describes a point that is located 4 units to the right of the origin and 2 units above the x-axis? So the origin is right here. If I travel 4 units to the right, that means I'm going 4 in this direction. And then after that, I'll go up, because above means up, 2 units. So go over 4, up 2, and it is only in that spot that you will place your dot. And then actually the dot is not what I'm asking for. And then you're going to tell me what the ordered pair is for that dot. The x value comes first, the y value is second. 2 more questions because technically we've already done number 8. Joswan is playing the integer card game in Miss Wells' class where red cards represent negative and black cards represent positive. Joswan is currently holding a red, I've already forgotten. I'm going to label them with their color names as well. Negative is red, positive is black. Joswan is currently holding a red 3. That means I'm going to put 3 right here. A red 10, 10 goes here. A black 2, and a black 3. What is his current score? Ooh, before I start adding, I see a 3 here and a 3 here. Plus 3 minus 3, those two cancel each other out. So you might as well simplify that already. This team wins. 10 is greater than 2. 10 minus 2 is 8. So you are choosing between A and B. We've already done 8. Last one. Product means we're multiplying. 10 times 2/3. But wait, you don't actually have to do any math. You are not actually choosing number answers for your answer choices. So let's think about 2/3. Is that less than or greater than 1 whole? 2/3 is less than 1 whole. So when I multiply 10 by something that's less than or smaller than 1 whole, I should end up with an answer that is also smaller than 10. And now we're done with our homework.